Number 12. Number 12. 10, 11, 12. Wait, do we need this? Oh, no, okay, I understand here. For the question, use information. The vertices of parallelogram A, B, C, D are this. So you have this drawn out, right, Kayleen? A is 0, 0. B is 4, 1, 2, 3, 4. You did send a piece of graph paper, I know. I would do it like this though. C is 5, 3. 5, 1, 2, 3. And D is 1, 3. Let's pay special attention here. So here's my parallelogram. It goes like this. Goes like that. Mine's not the best, but it'll get the job done. A, B, C, D. What is the area of the parallelogram? What is the formula for the area of a parallelogram? Area is base times height. They have to be perpendicular lines. You can't, you're not going to multiply this by this slanty thing. You need to just come up with how here can be your base and this can be your height. How tall is it from there to there? 1, 2, 3. What's the base? 1, 2, 3, 4. So 3 times 4. 12 units squared. Is anybody going to ask about 13 since I'm already there? Or no? Coordinates of C prime means you just take both x and y values and multiply them by 2. Because it's scale factor 2. That's where 10, 6 comes from for problem 13. Alex, what was your question?
Can you do number 11?
Gladly do number 11. Number 11, you could cut it into a rectangle or a triangle, or you could use the formula for a trapezoid, which is the area of a trapezoid equals 1/2 base 1 plus base 2 times height. And the two bases are the parallel lines. So if you plug that in, you get 1/2 of 14 plus 22 times the height. And again, remember the height has to be perpendicular, so it's not the 10, it's the 8. 14 plus 22 is 36. Half of 8 is 4. 4 times 36, 144 inches squared. You probably could cut it into a rectangle and a square or whatever, and figure it out. Okay, Ron.
Can you do number 7?
I would love to do number 7. More than life itself. Oh, yes. Number 7. Remember, pyramids and cones are 1/3. This might be a good one to have little notes with yourself. 1/3 of what it would be if it was a prism. Okay. And this is a. We have to. Do we have to assume that this is a 6? Oh, it says the height is 4 feet. Okay, so it gives it to us. So here's the gist. You think about this like it was actually a prism. Let's see if I can draw it. Maybe it doesn't look that way, but if this was a rectangular prism like this, it said it had a height of 4 feet. Not that you can actually see that. Maybe I should put it in dash. Here would be the rectangular prism that would enclose that pyramid there. And if you're finding the volume of that, it would just be area of the base times height. And the area of the base is 6 times 6. I don't know why this thing's acting all goofy. And you'd multiply it by 4, and it would be what? 144 but it is a pyramid. Anything that comes to a point is going to be 1/3 of that. So you're going to take 144 divided by 3. 3 goes into 14 4 times, and 3 goes into 24 8 times. So 48 feet cubed would be your answer. Does that help? Okay, Ron? You're just gonna be the same on tomorrow, I am absolutely sure. I love parade. Stritzel,
Number 2.
number 2. Number 2. Number. A small town occupies a rectangular land. Express the area of the town in scientific notation. Area is, Caitlin, length times width, right? That's how you find area. So you're going to multiply this, which is what? 4 times 10, I can't tell what the exponent is. What is that exponent? 6. You're multiplying that times 3 times 10 to the 6th.
Yeah.
So in scientific notation, how do you multiply that out? You multiply the 2 left numbers, you're going to get 12 times 10. What do I do with the 10 to the 6 times 10 to the 6th? How do I multiply them together? You do what? 10 to the 6 times 10 to the 6th is what? 10 to the 12, because you add exponents when you multiply. Okay, this is all well and good, except it's not in scientific notation. You can't have a 12 in scientific notation. It has to be between 1 and 10 or whatever, so you got to take this decimal, move it back one place, get 1.2. And since I made this one smaller, I make this one bigger. It's going to be times 10 to the 13th power. A house. Maybe number 4. So far, so good. Did we take this test last year? If a coin is flipped 4 times, it's the probability of getting heads all 4 times. So here's your coin. 1, 2, 3, 4 times. Probability of getting a head on all of them. Well, probability of getting a head there is a half. Probability of getting there a half. Probability of getting a head there is a half. Probability of getting a head there is a half. Probability of all of those happening in that order at that same time is those probabilities multiplied together. 1 times 1 times 1 times 1 is 1. 2 times 2 is 8. 4 times 2 is 8. Times 2 is 16. 1/16 times you will get 4 heads in a row. Come Atkins.
Number 6.
We're going to skip 5 out. 6 up here. A bag contains 4 red marbles. Here's my bag. 4 red marbles. Red, red, red. 3 blue marbles. Are they supposed to put 4 of them? Well, that didn't work very well, did it? Blue, 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 red. And 1 green marble.
And 2 yellows.
No, I'm doing the green first. Did you say 1 green marble?
There's 2 yellow marbles here.
1 green. I didn't get to the yellow yet. Killing me small. 2 yellows, okay, I'm sorry. 2 marbles are drawn from the bag, 1 at a time, without replacing. What's the probability of drawing 2 blue marbles? Well, the first one, it's going to be whatever the first one is times whatever the second one is. And you're not putting them back in the bag. So I draw, what's the probability of drawing 1 blue marble? Well, there's 3 blue marbles out of how many total? 2, 4, 6, 8, 10. But if I take a blue marble out, that's going to change the probability for the second one. Now there's only 2 blue marbles still in there, and there's only 9 total marbles in there. So whatever that multiplies out together, you can do some cross canceling or whatever. 2 goes into 2, 1's into that 5 times 1, 3, 1/15. 1 out of 15 times, you'll get 2 marbles. Had you put the blue marble back in before you drew the same one, it'd be the same. It'd be 3/10 times 3/10, and you'd get 9 100ths, but that's not the case right now, Madison Wellman.
How do you figure out these?
A who? Problem 8. Which is the following rule for this sequence? This is what I do, and I kid you not. This would be really what I would do in real life. I would make a table, and I would do this. Okay, this is your first term, second term, third term, fourth term. 1, 2, 3, 4. This is the number of the term. First one is 6, next one is 11, next one is 16, next one is 21. And you're trying to figure out what to do to like 2. What would you do to 2 to end up with an 11? But the first thing you want to look at is say, okay, what's happening between each one of these? This goes from 6 to 11 to 16 to 21, right? So what are you doing every time? Yeah, you're adding 5. Now when you add 5, that probably means you are doing what? Multiplying by 5 every time, because you're going up. See, if A, what is 5 times A give you for the first term? If it was just 5, the first term would give you what? Yeah, if A equaled 1, then you'd end up with the first term of being 5. If A equaled 2, the second term would give you 5 times 2, which is 10, correct? The third term, 3 times 5 is 15. Well, how much short are you every time? 1, so guess what you have to do? Add 1 to it. You could just do trial and error, by the way. They give you 4 choices. You just plug first term in. Does this give you that? Second term, you know. If n equals 3, the number of the term equals 3. I'm sorry, I should put n there instead of 8. 3 times 6 is 18 minus 1. That doesn't give you the right answer. It should be 5a plus 1. So does that work here? Is that, which one is that? B, I'm sorry, yeah. Sometimes you're so close that you don't see it. But you could just put, you know, n in for whatever. Number of the term, first term, second term, third term, fourth term. Landon!
How do you get number 5?
Wait, wasn't I just at number 5? Was I going to ask about number 5? Oh, lateral surface area. Remember what I said? Lateral surface area, LSA, is the area of just the sides. No bases. So you could figure that out. You've got this rectangle side here that you can see this bottom and that, because the base is a triangle. Okay? The base is the triangle. But there is a formula for it, and the formula says LSA equals the perimeter of the base. You find the perimeter of the base and multiply it by the height of the shape, you will get the lateral surface area. And that's not so hard to figure out because the perimeter is 3 plus 6 plus 6. Which to me looks like it is 15. And the height, if you set it on its base, the perpendicular line to the base is 8. So 15 times 8 will give you the lateral surface area, which is what? 120 centimeters squared. Which would be the exact same thing if you figured out the areas of all the sides. If you were looking for the area of this side that you can see, it would be 8 times 6, which is 48. If you're looking for the area of the bottom that you can't really see, that'd be 3 times 8, which is 24. And then the area of the left side that you can't see at all is going to be 6 times 8, which is another 48. If you add those together, you will also get that 128 on board. Yes. All is good in math world. Anybody miss 0 on that whole thing? Anybody miss only 1? 2? 17? Other question? While I'm standing up here. Taylor!
16.
16. 14. 15. 16. The area of the square is 25 square units. How many units long is the diagonal of the square? Okay, first of all, it's a square, Taylor, right? So its area is 25, which means every side would have to be what? How do you get, yeah, every side's equal, but what number times what number? In order to get area, you multiply two sides together. What side squared equals 25? What would every side have to be to give you 25? What number times itself gives you 25? 5. So each one of these sides has to be 5. How do I find the diagonal? It's going to have to be the diagonal of a squared, b squared, c squared, 5 squared plus 5 squared equals c squared, 25 plus 25, c squared. C squared equals 50. C equals the square root of 50. Noah, I don't know where you went wrong, Noah, on yours. I know you kind of had this. Is this the one you had wrong? I think it was. Breaking down the square root of 50, it's the square root of 25 times the square root of 2. The square root of 25 is 5, so you end up with 5 square roots of 2. Enchanting, isn't it? Raise your hand if we've done every problem that you got wrong so far. Alex.
For number 14, can you use our notes or reminder?
Number 14, let me look at it. What is number 14? Are you saying it's too many notes for you to rewrite on a separate piece of paper? Oh yeah. It's my hope though at some point that you can see these. I mean, you should be kind of acquainted with the repeating decimal fractions. At some point in your mathematical lives, they'll come to life and you'll spring into action. Is that it? Are we done? Nobody else? No? Oh, you kids are incorrigible. Strutzel says, let's do one more.
Number 9.
Number 9. Number 9. Which of the following represents a union of the set of prime numbers and the set of composite numbers? Well, which of these describes the union of the sets of prime numbers and the sets of composite numbers? Well, you have to know pretty much every number is either prime or composite, right? Except for, well, apparently negative numbers are not prime or composite, because I would have actually thought that you could put those in the prime or composite. Don't you think? I'm going to Google that. Can you not have negative prime numbers? What's that? Is that? Are you sure? Let's say it there. Anyways, here's the gist of that, people. There are numbers that, the only numbers that are neither prime nor composite are 0 and 1. Okay, why is that? The definition of a prime number is it has to have exactly 2 factors. Okay, and neither one of these, the only factor of 0, well, 0 could have bazillions of factors, I guess. 1, the only way to get 1 is to multiply 1 times 1. And 0, I guess 0 can't be what? 0 is neither prime or composite, but I'm not sure what the reason is. So let's just go with that and hope the question is the same tomorrow. I'm going to look up negative numbers, or why negative numbers can't be prime. 1 would be the one that I would see here. Did you put it, was the answer D or A? D. It was D. I'm going to look at it.
That is,
What? I should look in the book there. If I can't find a decent answer, I might exclude this question. Other ones? Okay, Ron?
Can you do 15?
I have done 15 before. Somebody could have told me it wasn't out there. It wasn't up there. Somebody could have told me it was up there. Expanding this, we just did this in 7th grade today. Gibran, how do you expand? We call that the distributive property, correct? Which means what? 5x by both of these things. What's 5x times 2x? 10x squared. X times x is x squared. And then there's a minus sign, so you have to put that minus there. 5x times 3 is, 5 times 3 is 15, and you still have that x. And x squared minus 15x. Completo? Stop. I will put this